Okay, continuing on basic integration techniques, which is just basically, it is the basic integration, but it's all the tricks that go with the integration you've already learned. So yesterday we did an example where it was inverse tangent. So this is our second example. And it is going to be another one where it's a quadratic, but this one's a little different. This time the quadratic is underneath a radical. So we have an integral, and we have 1 over the square root of, and it's negative 7 minus 8x minus x squared dx. And you look at this one, and you first thing you always try is u sub. And if you put the quadratic, make that your du. When you take, or make that your u, when you take the du derivative of it and get a du, it's going to be a negative 2x, and there is no x in the numerator, so you know it can't be u sub. So I'll write that down again. Can't be u sub. Because no x term in numerator. So you know you're going to have to go to something else. Well, anytime it's a quadratic, especially since it's underneath the square root, you have to think inverse trig. And which one of the inverse trig functions had something under the square root? It would be the inverse sine. So let's look at what the sine, if it's inverse sine, if the answer is inverse sine of u over a plus c, then the integral is going to look like the integral of 1 over square root of a squared minus u squared du. So if we look at ours, we have the integral side, we have the 1, we have the over, we have the square root, and then where do we fall apart? We need a squared minus u squared, and we have negative 7 minus 8x minus x squared. So what we have to do is we have to complete the square. The funny thing is, though, it's really kind of strange. So let's pull this over here to the side. And we're going to start with what's the quadratic that we have to. So what do we have to do? We have to make this inside here look like that. And how are we going to do that? Well, we write negative 7 minus 8x minus x squared. And we go, I don't like factoring things like that, so let's pull out a negative sign. So when we pull out a negative sign, we get negative of x squared plus 8x. And then I don't want to pull the negative 7 in because I know I'm going to be completing the square because of an a squared and a u squared. So I'm going to leave the negative 7 alone. So I'll leave a space and I'll have a minus 7. And then we go and we take what b is. So we need b over 2. That means it's going to be 8 over 2, which is 4. Two things we're going to do with that. The first thing we're going to do with that is we're going to do, what is our factor? Our factor is going to be x plus 4, all that squared. And then what are we going to do with this 4? We're going to take it, and to put it inside here, we're going to square it. Which means I'm going to, right here, I'm going to add 16. But the thing you need to keep in mind is there's this negative out in front. So if I combine these two, that means that is actually a negative 16. So what do I have to do to match it up and keep it balanced? I have to add a 16. I'll repeat. There's a negative sign pulled out. Before I can decide what to do to balance, I have to multiply that negative times whatever b squared is. That becomes a negative 16. Since I put negative 16 in there, essentially, I have to add a 16 outside to keep it balanced. So what I end up with is, I take that negative sign down here so that there's a negative of that whole thing squared, and then 16 minus 7 is going to be a plus 9. So what does this look like when I finish? It looks like 9 minus x plus 4 squared, and that looks just like a squared minus u squared, which is going to go up here. So now when we change that integral, let me write it all out again. So we had the integral of 1 over the square root of negative 7 minus 8x minus x squared dx. And we're going to change it, using completion of the squares, to 1 over the square root of 9 minus x plus 4 squared. dx. And if you don't believe me, go ahead and multiply that out and combine the like terms and see if you end up with negative 7 minus 8x minus x squared. You should. And then when we get it in this form, then it's just an inverse trig. We go, okay, well there's a. A is equal to 3 because a squared is 9. And u is equal to x plus 4. And here's where we have to be careful. It's x plus 4. Let's check du and make sure there's nothing funky going on. It is dx, so that makes that easy. No problems. We can go straight to the formula. That means that this integral is going to equal the inverse sine, oops, screen skipped, sine inverse of my u, which was x plus 4, over my a, which is 3, plus c. And I don't have my That's Easy button. Hopefully I'll get that Monday so I can start pressing it again. Alright, so that's it for inverse trig kind of functions. Now the next thing we're going to do is what I call subtle substitution. And y'all are going like, it's not so subtle. But it's a subtlety. And those are the hardest things to spot. Alright, so it is called subtle substitution. Which means it's a u sub. Okay, so on this one, what if I give you the integral, well, maybe, go away, the integral of 1 over e to the x plus e to the negative x dx. And you go rut-row, because if you do a u sub on this one, if you did u is equal to e to the x, du is e to the x dx, that didn't help so much. Because I got the e to the negative x. And if I say all of that is du, I don't get anywhere. I don't get rid of anything. My problem is on this, you'll notice there's only a 1 up here. That has no e to the x, e to the u's. There are no e to the u's up there. And we know that the derivative of e to the x is e to the x, and e to the u is e to the u. So if I don't have anything in the numerator, that means I have a problem. All right, so let's rewrite this thing. We're going to write it as the integral of 1 over e to the x plus 1 over e to the x dx. And we're going to play with the algebra. I would really like to not have a fraction within a fraction, so what we're going to do is we're going to multiply the top and bottom by e to the x to clear out that fraction there. This is the one I'm having trouble with. So I'm going to clear that out by multiplying. It's just 1, my favorite number other than zeros. Right? So if we multiply that out, and remember, this is a parentheses, so you're going to have to distribute it times each term. When you do that, what you're going to end up with is the integral, and you're going to have e to the x on top, and then you're going to have, when you multiply that, e to the x times e to the x is e to the 2x. And then when I multiply e to the x times 1 over the x, it's plus 1. Oh, now we're getting somewhere. We're getting somewhere. The other way to look at this is instead of saying e to the 2x, what if I say it's e to the x squared? Like that. Now we're starting to make some progress, because that looks like inverse tangent. The only problem is I have this e to the x dx out here. Except remember earlier I said something about what if u is equal to, hang on, what if u is equal to e to the x? Then du is equal to e to the x dx. And that's the subtlety. Because whenever you're taking a derivative of e to the x keeps appearing. So look right here. That's du. If we make that du, then we look at it again, and we realize this is going to be 1 over u squared. This is going to be u squared, right? So this whole thing becomes 1 over u squared plus 1, which is inverse tangent. So we just rewrite this, and it's going to equal the integral of 1 over u squared plus 1 du, which that is inverse tangent, and it's 1 over a. Well, in this case, we go right here. So a is equal to 1, and u is just equal to u. So I end up with 1 over 1 tangent inverse of u over a plus c, and then if we do our substitution back in again, we end up with tangent inverse of our u, which was e to the x, over a, which is 1, so we just call it e to the x, plus c. And that wasn't too bad. The trick here is this one. You have to realize that every time you take the derivative of e to the x, you're going to produce an e to the x. And it's missing originally, but by doing a u sub, I can make it come back again. Okay, for our next trick, we're going to look at, remember the conjugate method we used way back when we were doing limits? Well, we need it again. Because, so this is our example 3. So we have the integral of 1 over 1 minus cosine of x dx. And you look at it and you know it's going to be a problem because you look down here and there's no sine x in the denominator, in the numerator. So no u sub. It's not going to work, right? U sub will not work. So we go, okay, well, 1 minus x, it really bothers me. But if you remember the conjugate method was for clearing out radicals. It's also used for clearing out trig functions. Because it would be really great if that was a cosine squared. If it was cosine squared, we could use a trig identity and really be in great shape. So what we do is we take that and we're going to multiply top and bottom. So this is 1 minus cosine of x, and its conjugate is 1 plus cosine of x. And if we multiply by 1 in the form of 1 plus cosine of x, then we're going to clear out our problem in the denominator. When we multiply the numerator, the top, we're going to get an integral of 1 plus cosine of x. And in the denominator, we're going to end up, this is the difference of perfect squares, we're going to end up with 1 minus cosine squared x dx, which is great because if you remember your trig identities, then you'll remember that this is just sine squared of x. So this whole thing becomes, and what we're going to do is, now that we've done this, hang on, let me just write it out. So you end up with 1 plus cosine of x over sine squared of x dx. Okay, we're not out of the woods yet, because when I take the derivative, if I use sine is the u, that's u squared. The problem is the derivative of sine is not 1 plus cosine. So what I need to do is that trick where I've been trying to get y'all to do this all the time. Whenever you have two things in the numerator and one in the denominator, then you just break this into two fractions. So it's going to equal the integral of 1 over sine squared x plus cosine of x sine squared x dx. The first fraction can be integrated if we just use a trig identity. The second was going to require u sub. So for the first, we're going to break it into two integrals, separate it. We get the integral, and 1 over sine is cosecant, so it's going to be cosecant squared of x dx. And we know what that is, or you should. And then I'm going to integrate the integral, and I'm going to do cosine of x over sine of squared x dx. And for the second one, I'm going to go, okay, well, u is equal to sine of x, and du is equal to cosine of x dx. So this whole thing becomes du, and this becomes u squared. For this one, we know from, remember when we did derivatives? The derivative of, and remember, it's cosecant, cotangent. So the derivative of cotangent is cosecant squared, but they're negative. Since there's no negative here, I know this has to be negative cotangent. Oops, not squared. It's cotangent x. So the integral of cosecant squared x is negative cotangent x. For the other one, this whole thing is going to become plus the integral of 1 over u squared du. Well, we can rewrite 1 over u squared as u to the negative 2, right? And then once we write that as 1 over, okay, actually, let me, yeah, I think I have enough room. Let me write this one step at a time. So 1 over u squared. So where are we at? We have negative cotangent x from the first term, and then plus the integral of u to the negative 2 du, which equals cotangent x, that's a negative cotangent x. And what is the antiderivative of something to this negative 2 power? Well, it's going to be minus, because, actually, let's do plus. It's going to be u to the negative 1 over negative 1 plus c. We don't want to leave it that way. We want to substitute back in what our u was. So we're going to end up finally with negative cotangent of x minus 1 over sine of x plus c, but we can't leave it like that because we know what 1 over sine is. So what would we start with? So our integral of 1 over 1 minus cosine of x dx is equal to negative cotangent of x and then minus cosecant of x plus c. So you have to remember inverse trig. You have to be able to complete the square to get to inverse trig. And you have to remember your conjugate method. Alright, so I went through that other one. The one that y'all seem to have the most trouble with, strangely as it may seem, is completing the square. So I wanted to do one more example of completing the square. So for this one, it's another example of completing the square. More completing the square. Okay, for this one, for my next trick, we're going to do the integral of 1 over the square root of 3 plus 2x minus x squared dx. And so I'm going to give you another hint. So when there's no radical, it should be inverse tangent, and for it to be inverse tangent, it has to be u squared plus a squared. If there's just a radical, so the way you spot this is, if the x squared term's positive, and the other term's positive, it's more than likely inverse tangent. So I look right here, and it's a negative x squared. Well, that tells me it's probably a squared minus u squared. So that makes me think of the pattern a squared minus u squared. So I'm going to complete the square after I factor out that negative. So I come down here, off to the side I go negative, and I just pull out the x in the x squared term. So it's going to be x squared, and then it's going to be minus 2x because I'm changing that sign right there. And then I leave a space for my b squared, and then that 3 I'm just going to write outside. I didn't do anything to it, I didn't factor anything out, I just left it outside because I don't need it. Then I come up here and I go, okay, what's b? b over 2 is equal to negative 2 over 2, which means that's negative 1. So that tells me that this factor is going to be x minus 1 squared. So I use that once there. I also am going to take it and make it negative 1 squared. That means it's plus 1 up there. Now, since I added that 1, remember I got to take this negative side and multiply negative sign and multiply times the 1. That means I have a negative 1 here. Since I have a negative 1 there, I have to add 1 here. So the whole thing becomes plus 4. So I get x minus 1 squared plus 4. So my integral, which was the integral of 1 over the square root of 3 plus 2x minus x squared dx becomes the integral of 1 over the square root of 4 minus x minus 1 squared, where my u is equal to x minus 1, my du equals dx, so no weird stuff going on that I have to worry about, and my a is equal to 2. And I look at this and I recognize that that is inverse sine, so I know that the answer is sine inverse of u, which was x minus 1, over a, which is 2, plus c. And we've done another tricky one with completing the square. Now y'all should go to the textbook online and practice.